Good evening. It is Wednesday, and this is episode 3 of Workshop Wednesdays. Hey everybody, welcome in. How are we all doing? James, I see you, buddy. I see you stacking up some questions already. Awesome. Love it. We'll get to those in due course, right? Right, okay. So tonight we're going to try a little bit of an experiment with the stream. Something that I have enabled for my Twitch stream. You can probably see in the background here, I've got my sub siren. And essentially my sub siren goes off anytime somebody subscribes to my Twitch channel. I believe I've got this hooked up to YouTube now, but there could be a bit of an issue, which is why it has been an experiment. The idea is anybody who subscribes while we're live streaming should in theory sound off the sub siren, and their name should appear on the screen just here, right? So the issue that I'm seeing is there might be some delay in the notification from the YouTube API to come through and say, hey, someone subscribed. So we might see people sub and there not actually be a sub siren event. I won't even know that that's happened during stream, which is, like I say, why it is an experiment. So I'm going to go ahead and enable the sub siren. I'm going to power it up. Right, here we go. It's reach over and power up. That's the sub siren now enabled. Hey Carol, welcome into stream. How are you? I hope your Wednesday is treating you well. So tonight we're talking all things 3D printing. We're going to be talking about how to up your game if you are if you're new to 3D printing or consider yourself a beginner. I'm more than happy to answer any questions which come up in chat, which I know James has already stacked a question up here. And I think we can answer some of that. I'm doing okay, thank you, Carol. I'm doing okay. Yeah, life in general is pretty busy. I'm gonna say hell. There's no secrets here. So I've ordered. I know a certain someone. Ray Fish has just subscribed. Thank you so much for that. Well, that's a proof of concept. It works. So ultimately, this is going to be fun if this goes off all night. So ultimately, I've got my hydroponic greenhouse set up, and it is currently it's a Dutch bucket system, and I've got 3 Roma tomato plants, and I've got how many? 5. I've got 5 chili plants. I got 4 jalapenos and 1 cayenne. And what I'm hoping for is to be able to automate the whole timing of the watering cycle, monitoring of the nutrient, monitoring of the pH. So I've gone out and bought some bits and pieces to allow me to experiment. And you can bet your bottom dollar 3D print is going to play a part for the enclosures, for various different bits and pieces that will require to get that project up and running. I am more than likely going to make a video about that and yeah, post it up on YouTube. So keep your eyes peeled for that. So James, let's get to your question. Let's get into this, right? So first things first, we've got a question saying, are there any 3D printers that print from more than one angle? As I see it, the 3D printer sort of prints on 2D, just building up layers. If you had a head on the sides, could potentially print some more unusual shapes with less supports. So that I haven't seen. So there's two types of 3D printers that you can get. One is the Cartesian, the Cartesian and Delta printer style, the FFF, FFM, FDM. There's a number of different acronyms that are kind of interchangeable in this arena. So you got the plastic pushers that push a piece of plastic through a nozzle, and as you say, it draws a 2D slice of an object and then raises up a given amount for your layer height, and then draws the next 2D and the next one and the next one. So the other style is resin-based printers, and I've got a resin. Let's see if I can get out of the way here. I've got a cardboard box, right, on my desk, and behind or underneath that is an Anycubic Photon S resin printer. It works in the same way that it produces a 2D layer, whereas a standard sort of filament-based printer draws a 2D slice, and it draws it almost like as if you put a pen, a plot, but it's extruding this plastic. The resin-based printer, it uses light and shines UV light through an LCD screen to expose the whole layer. So you can have multiple items on the print bed for the resin printer, and it doesn't change the time it takes to print the overall batch. It will take as long as the longest item. So a single if a single print, right? I haven't seen any 3D printers that do printing from the sides and do all weird stuff, but I have seen some very interesting concepts for where 3D printing could be going, in that you have a light source that projects into a gel, and that solidifies it, and it goes all the way around to produce the 3D object. That's pretty cool. So we'll have to wait and see. I mean, what you've got to remember, the reason that we have 3D printing available to us is because patents expired. This stuff has been, commercially available since like the 80s. So I want to see what the next iteration, the next generation. James, were you not subscribed? Were you not subscribed? Chris, welcome. Soul Oracle, welcome. I hope you're doing well. So that's ultimately, hopefully answered your question. There's lots of different things, like conceptually, that could be there, but also, you've got to think about, are you using the right technology? So if you're looking at doing things on the sides of things, maybe you want to be looking at CNC milling, and specifically 5-axis CNC. So here we go. Testing the unsubscribe, resubscribe. So yeah, that probably, well, if you did it again, it won't work, right? But I think the capture mechanism for the sub siren is essentially blank. So I could have, in theory, some 400 odd people unsub and resub at the same time and set the siren off into an absolute frenzy. But from that point on, it won't do it again. So we're all good. We're all good. So you're learning how to slice with Cura. Well, Chris, we can do that, right? We can cover that. What is it we're trying to do? Talk to me. Hopefully the latency is pretty low on chat interaction. We should be looking at somewhere in the region of about 5 seconds latency between you dropping the message and me picking it up. But yeah, I can certainly get Cura up and running. In fact, let's do that. So I'm running Ultimate Cura. Yeah, we could do that. Drop me a DM in Discord. So this is an adapter. This is an adapter to help you remove coffee, right? Yeah, you can often find that the design of something is much faster than, you know, certainly the printing. Ground coffee, I think you meant to type, wasn't it? I'm sure that's what you meant, right? You know what I'm saying? So, what, are you going to drop me a DM with the STL file? Yes, exactly. Exactly. Yeah, just drop the STL. That'll be a lot easier. And stick around until the end, right? Because I've got a killer tip. If you've got STL files that you want to modify, I've got a killer tip for you right at the very end, okay? Talk about retention stats. Yeah, right? Right, James? So I've got Discord open here, just waiting for the message to come through. Although there is a file size limit, so depending on what it is, right, we can send. Ah, yes. Let's have a look. Okay, the file is down. Let me just load it up in Cura. Let's just have a look at this coffee product. Okay, so this is a scoop, right? Is that what I'm looking at? A scoop with some text. No problem, James. You lurk away. Make sure you keep the audio on, though, so you can follow along. Right, okay, so let's have a look at what we got going on here. So if I just switch the scene to my app PC. Well, that's rubbish, isn't it? That's a failure right there. Let's see if we can fix this. One moment. Well, we have a technical problem. If you like to bear with me one moment, we shall rectify the situation momentarily. My broadcast software has decided to have a moment. Okay, so there's that. Has that fixed it? Has it fixed it? I think it might have. Well, that's rubbish. That's absolutely rubbish. Well, this stream is going to be about me fixing my problems by the look of things. Okay, you're going to lose my audio for one moment. Okay, we're back. Okay. I'll fix that another time, I think. Let me just hack it a moment. There we go. So if I go here, it's going to have the same problem. So if I hack the same thing... Well, this is all about keeping things running, yeah? And then we'll just bring you down here. That's what happens with live streams, right? A stream prep stream? Ha ha ha! Cool, okay, no worries, no worries. I hear you. Right, let me see if there's another message. Are you sending over another version? Ah, hey Frank, welcome in. Okay, apologies for that technical glitch. Okay, I'll go with this. I'll go with this model, right? It's no big deal. It's all good. All right. So the first things first. We load in our file, and we are going to just go around it. I just want to see. It's been a while since. There we go. I want to see how things look here. New one in Discord? Okay, well, we'll use the new one then. Okay. Alrighty. So we've got a nice coffee scraper. And so just give me a bit of context. What's the issues that you're having slicing this object? So presumably, first of all, you have Cura set up with the dimensions of your 3D printer. So that's the size in X and Y, and also the size in Z. So you get your full build volume. You've told it what size nozzle you've got. You've told it what diameter filament you've got, and you've told it whether or not you've got a heated bed, all of that good stuff, right? So what is it we're having issues with in terms of slicing this particular item? So ironing, ooh, that's a feature that I've not used in Cura or in Slicer. So we're looking at ironing. All right, let's see if we can figure this out. So we've got currently my print settings here are 0.2mm layer heights, which is considered a draft quality. Do you need ironing wood over texturing a bit enough? Have you got an example picture of the result that you're getting? Okay, so we've got this standard texture here. That's the sort of standard. What layer heights are you printing? 0.2. How many top layers? And you appear to be printing this in a translucent filament. Is that right? So you're printing 225 degrees C on the nozzle, 50 degrees on the bed, and it's PLA. Okay. Yeah, I can go with those settings. I'm cool with those. Okay. Have you temperature calibrated this material? Have you done a temp tower? Because what I'm seeing here could be signs. So, like for example, in the bottom one, where there's no ironing going on. So, ironing. For those of you who don't know, this item here. Let's just make sure you guys are actually seeing the right thing. Right. Let's go full screen on this bad boy. So, ironing on a 3D print is essentially where you take this pattern of the print. So what you're seeing here is the individual layers or lines of the plastic as the extruder has drawn that 2D top layer. What ironing does is it proves to smooth that top layer, and it is intended to improve the surface quality, right? Okay, so first things first, the temp tower. A temp tower is essentially a model that has certain geometric properties like overhangs and bridges, and you can go to Thingiverse, search in the Thingiverse and type in temp tower, and you get different ones, because in the layers in the blocks of the tower are temperature values, and you get ones for PLA and ones for PTG, ones for ABS. And ultimately, what you do is you load that file into Cura and use the G-code modifier, and you find out where your transitions are, and then you change the temperature of the nozzle going from hottest to coolest, and the output of that will tell you the optimum print temperature for your material. So once you've got that G-code file saved, keep it in a library somewhere, and every time you get a spool of new filament, that's the first thing you print. You print the temp tower and you find out the sweet spot, so you get the best layer adhesion, you get the best layer quality, because sometimes, you know, I'm looking at that could be running slightly hot, which may be contributing to your problem, because there's nothing worse than trying to push plastic around which is too hot. I mean, you can definitely see that artifacting like here in the center. Oh, it would help if I switch scene. Right here in the center between the colon and the 4, that looks like heat distortion to me, just right there. Every time I get a new spool, I'm in the middle of a print. Lost algorithm. That is so true. Sure, but the temperature settings you use, regardless of the slicing platform you're using, you're gonna see potential temperature issues, right? So I tell you what we'll do. Let me fire up my printers. Give me 1 second. I'm gonna fire up my printers. And we'll do a live print test. How does that sound? So, catch up with me in Discord later, and we'll talk about printing temp towers. But ultimately, that's what you need to do. In fact, let's go and have a look at what a temp tower looks like. Okay, so you get the different varieties of temperature tower. Some people have actually produced the G-code as well, I can see, which is very nice of them. Thank you very much. It's up to you whether or not you want to do that yourself. So, for example, if I click on this one here, and this one, what temp tower ready to go? So this goes up to 230. Down to 190. So that's ideal for PLA. That's ideal. And let's have a look at this in the 3D viewer. So what we've got here is we've got some overhang geometry just here. We've got a bridge, and we've got these different sort of definitions. We've got text in here, and ultimately what you're going to do is you're going to print this out and you're going to try and break it, and you're going to find where the weak points are, because if it's too cool, you don't get the layer adhesion properly and things will just break away, and too hot, you'll see things like the digits in the text distort and being horrible, right? So goes from 31 to 48. What's that? So yeah, this is literally all you're doing. It doesn't really matter on the layer heights, right? You're gonna be That's okay. No worries. So we're looking at trying to calibrate your filament to your printer. Remember what we said in a previous live, that if you bought a CR10 V2 the same time as I did, and those two machines were in the same production line, we have two different environments. So my room temperature is different to yours. My humidity is different to yours potentially. So there's a lot of variables that are outside of your control. So when you pick up a spool of filament and someone says, you have to print this at 190 degrees C, because anything hotter will cause it to have crappy quality. Well, that's not strictly true. Put it in your 3D printer, run a temp timer, and find out what is the sweet spot for you. There are so many variables. Right, let's get the beds warming up, and let's quickly do a bed level of each of these, just to save time. So, heating up the bed on both machines, and I'll print two of these in a. Hopefully, we can print them in the duration of the stream. Let's go prepare. So that's that one moving. Let's get the other one going. We'll do parallel printing here. I've actually taken my print server offline, which is kind of like irritating. But it is what it is. We'll give that a minute or two, and then once we're starting to get some temperatures close to printing, what we're going to do is do a bed level exercise. Right, if these G codes are configured, how would you do that? My setup is your dream. I have the 3D printer relegated into the basement for now. Oh, well, I'm in my attic, right? At least your basement's likely to be cool. My attic is roasting hot, especially in summer. I know I'm in the UK and all, but it gets dang hot up here. I could break a sweat on really, really hot days. I could break a sweat without like doing anything inside of like 2 minutes. That's why there's that big window right there. So I've got three printers for FDM. One CR10 V1, two CR10 V2s, and I've got the Anycubic as well. But I bet your basement is cool. Okay. Right, so let's figure this out. While we're waiting for... We're going to wait for these printers to get 10 degrees warmer on the bed. So I'm going to be printing in PETG. That's pretty renowned for stringing. And we're going to do a test print. And we're going to find out whether or not we can get ironing to work. It's not a feature that I've needed to use. Never really used it, so I can't talk to it with any level of authority or expertise, but I can share my experience and I can try and figure out what's going on. So, okay, where were we? So we're looking at that. Let's bring our slicer back up, and I am actually going to use Prusa Slicer. Because I believe ironing is available in Prusa Slicer also, and it is configured to my machine. Right, so let's bring in the file. Yeah, it's actually useful learning multiple slices, if I'm honest, because if one kind of goes down on you, you've got another one, right? Alrighty, so let's have a look at my print settings. My layer height is currently 0.4. So let's go down to the settings you had, and then we'll go back to the platter and we'll look at slicing it. So this is default. We're gonna lose some of your text detail because I'm running a 0.6mm nozzle. Are you running a 0.4, I'm guessing? Right, let's get these beds auto leveled. Okay, that's those beds leveling off. One of the things, a tip I would suggest, anyone who's running a 3D printer with a bed of 300 by 300 or larger, auto bed leveling all the way. All the way. Because if you get a visualization of your bed, you'd be surprised on how it actually dips. But yeah, auto bed leveling. Oh, it adds a little bit of time at the beginning of a print if you have it set in your G-code to go every time. But essentially what I do is I power the machine up, get the bed up to printing temperatures, and then do a leveling exercise. And then for the session of printing that I'm doing, it's set, it's all good. Saves you so much time. You don't have to level every single print. Not unless you really crank on the print to get it off and you know you've moved the bed. Okay, so let's transfer a stock G-code file to one of the printers. Hopefully I don't freeze a camera up by plugging in my memory drive, and we're gonna go ahead and export the G-code. Are we flashing here? Oh, it's not registered. One moment. So those Windows noises are me. Please ignore. We're looking for the card to register properly. For some reason it's not. There we go. I think. Yeah, there we go. Okay, so we're exporting a stock. So body one is a stock file. Now let's see how we do. Ah, I did freeze. I called it. I know, right? Okay, give me a second. I can fix that. I need more USB ports. You'd be surprised, right, on how much bandwidth and stuff these cameras take on the controllers, and how they don't typically. Oh well, that's not very nice. There we go, and we're back. Didn't want to play ball, so it might go again. Yeah, right. But I gotta think about, is it gonna freeze again? Is it gonna freeze again? No, we're good this time. Yay! Okay. Ah. Okay. So let's figure out ironing. So from what I understand is ironing is a modifier. So if we right click, you can add a modifier. Okay, what we got? If anybody knows in chat how this is done in Prusa Slicer, that'd be cool for you to just yell out. Comes up on top and bottom layers for Cura. Okay. Layers and perimeters. What do we got? Got an option for. Got an option for layering, ironing even. Okay, give me 1 second. Let's see if I can find out about ironing. There's bound to be something. I will not subject you to me searching for it. Just give me 1 moment. It just goes to show, right? Doesn't matter how far down the road of your learning journey, there's always more to learn. So we've got Prusa Slicer. We're just doing a quick Google search here. Prusa Slicer. Ironing. Okay, what do we got? Enable ironing. It is in the settings. I've got it. I got it. I know where it is. So let's just remove that layers and perimeters. Let's switch back to the PC screen. Right, so if we go up here and go into print settings, should be, where did it say it was? So on the infill, it's on the infill tab. Because of course it'd be on the infill tab when you're talking about a layer. Right, where is it? It's supposed to be a tab there for ironing specifically, which doesn't appear to be here. So is it a case that I don't have the right version? .2. So which version is this available in? It's from 2.3. Well, of course it would be from 2.3. We've got an update button here. Alright, we're gonna get this. I'm not gonna let this drop, let me tell you. Win64. I am not gonna let this drop. Fingers crossed it doesn't ask me to reconfigure everything, because that would suck. I won't hold it against you. You're not wrong, James. Right? You are not wrong. All right, what do we got? Okay. It looks like it's picked up my settings. Let's have a look. 0.4 layer height. 400, yeah. Bed shape. 300 by 300, yeah. It's got everything. Oh, well, that's handy. That's handy for you guys because you haven't got to watch me struggle. So let's bring in the file, and we want to change the layer height. Print settings down to 0.2. millimeters layer height. We want to go to the infill, and now we've got the ironing button, right? So let's go enable ironing. So we've got ironing type. We've got all top surfaces, topmost surfaces only, all solid surfaces. I'm going to go with the default with all top surfaces. And I'm going to keep everything else default, right? So let's go ahead and slice this. Go to the platter. Let's slice it. Let's have a look at what this looks like. So it's showing that there's like this. Let's have a look at what it looked like before. So this with ironing off, and let's slice now. You got these jaggedy lines where it's like doing the infill, but then when we put the ironing on, and then we run the slicer, we've got these very fine sort of lines. So let's try this out, shall we? I have no idea whether this is going to work. So we'll export that and we'll call this body 1 and we'll call it iron. Right, done. So we'll eject that. Okay, and now we're going to set the printer off. 50% of your job, military job is Google. Oh my. 50% of Russian and Chinese intelligence is Google. It's just work for Google, right? Yeah, it's all good. We'll see, right? We'll see. Okay, so let's set these printers off because they're going to take about 24 minutes. So it's probably going to take closer to 30 minutes to print these out. So let's just get them going. Hopefully I don't have any bad adhesion issues. I did. Right, there we go. And we're off to the races. So those are now we're gonna go off and see. We're gonna go off and see what that looks like. Now, bearing in mind, okay, so bearing in mind, I am using PETG, so any defects are going to be magnified. Let me show you what I mean by that. So I've got this is an adapter that I've built for my CNC restoration. This sits over the top of a stepper driver controller. And it has a screwless retention system for a fan to give direct cooling. Now, if you look here, you can see where let's see if I can get the light to catch this in a way that you can see it the best, right? I've got two different layer heights in here. One, the bottom half of the adapter is printed in 0.4, and then up here it goes much finer. I think I went 1.5 to 2, sorry, 0.15 to 0.2 in this area because I needed the definition in these retention clips. But if I switch to the microscope and getting up close on this, right? In fact, you can see the lines look pretty uniform. They look pretty nice, apart from a couple of areas where there's been overhang. But if I switch to the magnifier, let's get into this and get up right close. We can have a look at the layer lines in real detail. So here are the layer lines for 0.4, and then here are the layer lines for 0.15, right? But there are some defects. So let's have a look at the defects. So down here, we've got some pillars. And on the edges of the pillars, we've got some stringing going on. Let's see if I can... Apologies for the shaky camera. Let that be better. Right, so we've got some strings going on. This is a artifact of PETG, right? PETG, it's the same plastic that is made, the water bottles are made from, but it's had glycol added to it so that it's easier to print. You do it! Welcome into stream, buddy. Hope you're doing well. But you can see some defects on the right hand side where we've got some layer change or where we're trying to close out a loop, all that sort of stuff. So on close inspection, something which you initially thought was like super clean, well, maybe not so much when you get right up close and look at it. Right? So we'll take a look at the prints, the test prints. Let me just check bed adhesion. Want to make sure that both of them are actually sticking to the decks of these. Yeah, both look real good. Oh, were you? Well, thanks for lurking. Did you see that the sub siren is now hooked up to YouTube? We've had 2 sub events which have triggered. Is it 2 or 3? 2 sub events. I'll call it 2. We've had 2 sub events that's actually triggered the sub siren. Oh yeah. I've got a very basic sort of pop-up of text of who's actually subscribed, but volume is down. That's okay, man. But yeah, fingers crossed. If anyone is watching right now and is not subscribed, by all means hit that subscribe button. Primarily, if this is something you like watching, I would greatly appreciate that. But you will also trigger my sub siren. There is a caveat to that. There is a potential delay between the sub and the siren actually going off. Okay, straight away I can tell that there is a completely different sound between the 2 printers. So I don't know whether or not we've got some completely different bits and pieces going on in terms of how things have sliced, because the one was sliced on the old version and the new one's being sliced. I think that is probably against YouTube's terms of service. I know it's against Twitch's terms of service, so I don't think we'll be doing that. I'm not quite sure what that means. I don't know. Context of that is it's lost on me. All right, so while we're printing, I guess that brings me on. This is true. This is very true. But we like to try and keep things family friendly, so we need to act responsibly. So, what was I going to say? Bed adhesion. That's a big thing, right? My experience with bed adhesion is a bit of a checkered one. So on my first 3D printer, Frank, it was a scratch build 3D printer, Delta printer, and I printed exclusively in ABS, and it was an open build platform. And I was able to get away with any sort of warpage issues. Now, one of the things, one of the things I've noticed over the years is that certainly with new printers, when you start using them for the first time, the prints come out, oh, super sweet. The layers go down buttery smooth, and it's like, yeah, this is like amazing. And about 5 to 10 prints in, you start to develop bed adhesion issues. It's happened on every single one of my CR10s. Now, I have a theory about what's happening. I don't know for sure. My theory is that out of the factory, the print bed comes with a coating of something that aids bed adhesion. Bed adhesion is layer number 1 sticking to the bed of your 3D printer. And as you use your printer, when you get to that between 5 and 10 print, you have removed that material from the bed because it's now stuck to the bottom of your print, and your bed then doesn't want to behave. So, 2 major factors I would say are the biggest to get critically right in order to get the best bed adhesion you can. Number 1 is a clean bed. Wash it, stick it in a dishwasher, right? Let it wash with all your other dishes. When it comes out clean, handle it by the edges. If you're of a certain age, you'll remember CDs. If you're of a certain age, you'll remember cassettes. And if you're of a certain age, you'll remember vinyl. But we won't go there. If you remember when you handled CDs, you often stuck your finger through the middle and handled it with the fingertips on the edge so you didn't touch the actual disc. I want you to do that the same with your print bed, right? Handle it by its edges, reinstall it into your printer, and good to go from that point on. As long as it's dry, it's got to be dry. I wasn't going to go back that far. I do remember 8-track. But anyway, moving right along. My dad had an 8-track. Dude, that's just Squirrel. Betamax. Yes, I remember Betamax. Yes. I remember the quasi formats before that, but we're going to digress, right? This is a 3D printing stream, right? So let's keep on point. Let's keep on point. So the second critical thing that you need is correct gapping of your nozzle to the bed. Now, what you need to do is manually level your bed first time out of the gates, using the leveling screws in all 4 corners of your print bed. If it's a standard Cartesian type printer, whether it's a standard XYZ or a Core XY, it doesn't really matter. You use the 4 leveling screws. If it's a Delta printer, depending on how they've set the bed up, they might have 3 screws because they may only have 3 contact points at each of the towers, or they might have 4. Either way, level the bed, and then when you set the nozzle gap, you want a piece of paper to pull through with a slight bit of tension, almost like a ballpoint pen running over a piece of paper. That's the sort of feeling you should get when you're moving it backwards and forwards. Is the gapping called a spark gap? Well, if it's a spark plug, it is. If you're getting sparks from your nozzle to your 3D printer bed, you might have accidentally installed the plasma cutter option. Just saying. But yeah, we really need to have like that ballpoint pen feeling as you're gliding the paper in and out, and it's really important that you bring your print bed up to temperature. So bring it up to at least 50 degrees, and get your nozzle also up to temperature, and pull the filament out if it's direct drive, or pull it back maybe 10-15 millimeters, maybe, you know, half an inch if it's a Bowden setup, so that you don't get any oozing. You don't want any sort of filament coming through to actually compromise the measurement between the actual tip of the nozzle and the bed itself. We're currently at 66% complete on printer number 1 and 61% complete on the other. So we're ticking along. We'll have these prints very shortly. So yeah, bed adhesion, that can be one of the biggest frustrations people have with 3D printing. 3D printing is extremely addictive. I know with my Delta printer, I used to love watching the 3 vertical axes dance to create the XYZ motion. I could sit there and just watch the machine print and find that enjoyable and relaxing. I guess it's kind of like watching fish. But it's not so fun with the XYZ printers, the standard Cartesians, because yeah, it's more of a ballet. There's more moving parts going on. Adventure 3 model has been great to start with. I'm not Adventure 3 model. What's that? Is that the model of printer? Not quite sure if that's a 3D model or if that is a printer itself. So some people, in terms of bed adhesion, some people use glue stick. I know painter's tape works well with PLA, but for things like PETG, ABS, you got to get the bed temperature up high enough to get that first layer adhesion, and also to try and combat torsional forces from warping, and the glue kind of like lets go and it curls up and rolls up. Oh, it's a printer, okay. You sent a link to me. Is that in chat or is that in Discord? I don't know if it's getting trimmed from my view. Let's have a look. Let me just change my view. Change your perspective. Yeah, I don't see a link, unfortunately. I got it in Discord. I see it. Yeah, I mean, it's pretty standard. It is pretty standard. I got you. I see you. So you've got an enclosed printer, and it's that's going to be good for doing ABS by the looks of it. We got. Not sure I'm a fan of the detachable nozzle on that. Let's show you guys what I'm looking at. Build size 150 by 150. We got temperature ranges. Doesn't like to tell me the max temps, but yeah, I mean I'm not sure I'm a fan of that. That could be a source of a problem for inconsistent Z height on the tip of your nozzle. But I mean, there's aids that you can use to get your first layer, you know, the way you want it. And like I say, glue stick is one. Some people swear by hairspray. I've not really had any luck with hairspray whatsoever. So perhaps in the US you have different ingredients in hairspray that will assist the bed adhesion, or I need to buy a particular brand that has the ingredient, the active ingredient that will help bed adhesion. Yeah, so when you say a very quick clean out, what do you mean by that? Do you mean by like cleaning the nozzle? Lazy Man, welcome in. So we're talking about 3D printing. So if you are new to 3D printing and you have some questions about how to up your game, we can do a bit of a discussion around what your options might be. I've got about 6-7 years in 3D printing, and I'm still learning every single day. I've got a saying that if the day you stop learning is the day you die. Right, so we're doing something new. We're currently printing out some models, duplicate models, which one has got ironing enabled, one of them hasn't, and we're going to do a close-up view of that and just have a look what the difference ironing actually makes. So ironing is a process that the slicer attempts to smooth the very top layer of the 3D print. That's the idea anyway. We'll see how well... Excellent. So I'll cover FDM and resin. I've got an Anycubic Photon S in this under this box here. It's a DIY sort of light shroud. I get direct sunlight coming in through this rather large attic window, which causes me curing problems. So I just put my printer inside a box just to zero out the light. Well, welcome in, Lazy Man. By all means, if you're into 3D printing, laser cutting, CNC coming soon, and just generally powering up your game from zero, bootstrapping all the way, feel free to subscribe. Hopefully you'll find some value in the videos that I've produced so far. I've got a few on 3D printing using various different CAD tools from Fusion 360 to FreeCAD, and yeah, we're looking to go from strength to strength. I'm currently doing a live stream test for this month. We're on episode 3 of Workshop Wednesdays, and we're going to continue that to the end of the month, and we're going to have a review and see how well live streaming on YouTube is for transitioning over from Twitch. So, but you are very welcome. Ask any questions that you like. If I have the expertise to answer, I will answer it. If I don't, we'll go off and find out what the answer actually is. I only tested on one of your first designs. I had 2 problems with it. So what were the problems that you had? Oh, thank you so much. Thank you so much. Yeah, let's know what the problems you had, because we could be looking at resolving those. So one of the prints is completed. This is interesting. So on printer 1, the non-ironed print, that, let me just see if I can throw the other camera. This might be upside down. Called it. Right. Excuse the mess. Let's transform this camera a moment. We'll rotate it. Right, so that printer is the non-ironed, and these prints started at the same time. However, we can see over here that the ironed one is still running, right? It's still printing. Oh, Lazy Man, you triggered the sub siren. Thank you so much. Appreciate you, buddy. So yeah, that's what the stream is all about. It's about helping the community, those who are new to certain aspects. I've had a lot of struggles over the years. I am completely self-taught in all of this, from CAD to the whole 3D printing, and I know how frustrating it can be. And I don't want to be one of those YouTubers that demonstrates perfection every single time, because I think that's unobtainium. You know, it sets people up on a pedestal that some people get put off right away. There's a disconnect. I make mistakes all the time, and it's iterative learning. Absolutely iterative learning. Hard to write, easy to describe was the end where the nozzle leaves the part. There was like a little burnt in failure, so I guess it's kind of right. Okay, so you've got like a little bogey where the nozzle lingered a little bit too long and caused like a little indent, and then it moved away. Is that right? What slicer were you using? Yeah, let me know what slicer you were using. Okay, so we're currently at 93% on the iron version, and we're going to get the microscope in a moment, and we're going to have a look at both of those. Right, so that's Cura. Okay, cool. So we're currently using Prusa Slicer. Prusa Slicer, you can configure it. It comes configured out of the box for like the Prusa printers, but you can configure it. I'm running my Creality CR10 V2s off that right now. So this is the view that I've got right now for the iron version. Lazy Man, can you tell me what 3D printer you're using as well, please? Yes, I did. So you need version 2.3 or higher. We've got 2.31 here. And to be fair, I've just run the Prusa Slicer executable. I didn't run an install. It was pretty simple. FL Sun Q5. I'm not familiar with that printer, so you'll forgive me for one moment while I take a look at that. Let's have a look. Oh, it's a Delta printer. Oh, I love Deltas. I mean, I've got a bit of a soft spot for Deltas simply because my first build of I couldn't afford a 3D printer when I first got in to the game. And I couldn't afford a kit either. So what I did was did a lot of learning, and I built a Delta printer from scratch. It was a Rostock form factor. Parts from multiple different vendors, and I Frankensteined it, which is why I named it Frank. I'm great with names. I'm so creative. Okay, so we now have print completion. So let's remind ourselves. Here is the this is the ironed version. Let's try and remove these prints without like removing my hand from my arm. Right, that's number one done. And then number two. Okay, good stuff. All right, so I think first of all, on first inspection, I can definitely see a difference. So let's bring the overhead camera back. And we'll do a bit of this. So here is... No, that's the wrong one. So here is the first one. We've got a bit of artifacting on the edge. which is easily like broken away. I'm not quite sure what that is. Don't know if that's a bed adhesion issue or if it was just carrying around some additional material on the nozzle. PETG does like to ooze, and it accumulates material. As you can see, I'm just scraping it away with my fingernail, and it's coming away. So you can certainly see the nozzle lines on this top surface. Right. Now, here is the other version. Can we get a camera focus? Your focus needs more focus. Right. Okay, camera. You've ticked me off. I'm going to have to take manual control of you. It is quite shiny, I've got to be fair. That's probably one of the reasons having trouble with focus. Right, which camera have I got here? Yeah, I got the right one. Alright. So we now got this really shiny sort of effect going on. You can also see, I think, this is where the nozzle has come in. I mean, this very top section here, that looks pretty slick. Now, I wonder whether or not if we put some Z... Right, you can see where the nozzle is dragged across the surface here. And it's kind of like zigzagged. So I wonder if we put a bit of Z-hop in here, that would remove it. And then you'd have this, like, really sort of... I mean, that's night and day, right? I know it's difficult to see. This is probably the worst material, but you can see the difference between the... Oh, my camera's reversed. Why is that? What's going... What does baffled mean? Overhead. Right click. Transform. Rotate 180 degrees. That's really freaking me out. There we go. That makes a bit more sense now, doesn't it? Although I've just gone and squished. That's what we want. Right click. But yeah, that's pretty... Yeah, I know. So let's have a look. Let's get the microscope out and we'll see the difference. So let's go with the non-ironed version first. Let's get to a height that we don't want to be too close. We want it to make sense. Right, so what we're seeing here, let's turn the light down. So what we're seeing here, let's get a device that I can point with. This should do. It's gonna be a bit chonky, but you know. So here we're seeing the layers, the plastic being squirted out at the end of the nozzle. Right, and you can see the contours of the edge, the perimeters, the internal of the perimeters of the hole, and the infill. You can see all of that, right? Whoop, as he knocks the camera. Crazy dart. Sorry about that. You can't make out the text that well, just simply because of the color. So let's bring the iron version in. And straight away you can see I mean the section here under the microscope, you can see like these vertical lines where the nozzle's gone over the top, but when I look at it, it's shiny, right? And very much so. All right, you can see a little bit of the perimeters like you could before, but where's the keychain? Significantly reduced. And bearing in mind, I've not tuned this at all. All right, so these settings are very coarse. I've just thrown the job at the printer, and this is the result. So, significant improvement on what was there before, but you can see where the nozzle has been dragged around in a travel movement. So we've got don't allow crossing perimeters, so that's to help with stringing and such. And you can see where the nozzle's just been dragged across the surface, ruining that effect. So we probably need to turn on Z-hop, and we probably need to turn the layer temperature down because this looks like it's too hot. But yeah, I think that's pretty cool. So yeah, PLA will behave differently in that respect. So the hotter you get PETG, the glossier it becomes. And the cooler it is, the duller it becomes. So if you take a look at the bottom here, yeah. You can definitely see this is the iron version. So that first layer, you can see each of the individual perimeters, the infill. We're losing some of the detail on the text because of the diameter of my nozzle. It's pretty clear. If I run this at 0.4, then that probably would make things a lot better. So the second problem I try to explain, the top last layer pattern is not interrupted, is not an interrupted line. Instead of the slicer always chooses like areas that would be filled. Hope you understand. I'm not quite sure what the inference is on that one, Lazy Man. Apologies. You had Z-hop turned on. Well, I tell you what, we'll do one more test, right? So let's go and have a look at we'll have a look at Prusa Slicer. We'll go to the print settings. Let's have a look. What would we be looking for? So we've got ironing, so layers and perimeters. Okay, I think I'm going to drop the temperature down on this next print as well. What are we looking for? Under the advanced section, maybe? Okay, I don't know where Z-hop is on Prusa Slicer, so let's find out where it is. Let's do a quick Google search. Because Google's our friend. Extruder 1. Okay, right. Let's have a look at that then. So that'll be printer settings. Extruder 1. Z lift is currently 0. So if we add We'll add 1 layer height, 0.2 to that. And filament settings, we're going to drop down to 235. Let's go 10. 10 degrees is a bit much. 240. Let's see what that does. Platter and slice now. How long is so the Z hop is going to add some time to the print. So let's output that, and we'll output it to printer number 1. Let's get the bed warming up again. That's on its way. Right, so while we're doing that, we've talked about ironing, we've talked about bed adhesion. I think we need to take some time talking about materials, because it's really important to recognize the different types of materials that people will be printing in. So let's export the G code to here, and we're going to call this one body 1 dash iron v2. Out it goes. Right, so materials. The materials that we've got available to us, they're becoming like a plethora of like different materials that we've got available. And I think it's important to recognize that most new people will be printing in PLA. PLA is a really good starter material in that it's easy to print. You get good bed adhesion, and my camera is frozen again. Thank you, camera. There we go. Let's have a quick look. Right, okay, I got you. His question was limited. Okay, let's go back then. I think I've lost it in the chat. Apologies. Yeah, it looks like my chat window that I'm looking at right now, it doesn't go that far back. As I was saying, so we need to recognize that we've got PLA. That's the starter material. It's easy to print. You don't necessarily need to print it on a heated build plate. You can print it. So with iron, you don't see the areas, but I had different shiny areas. Yeah, I think so. I think that is an artifact of PLA, right? So, the reason I'm getting shiny areas on my prints is because I've got I'm using PETG. And the temperature of PETG, I suspect what's going on when it irons that top surface. Let's see if I can show the camera here. You can see how shiny this damn thing is. It is pretty shiny. There we go. Right. I think what's happening is the feed rate over that area is slowed right down, meaning the filament has the ability to absorb more heat because it's not passing through the nozzle and the heat block as fast as it would be under normal printing, right? So that's why mine is shiny. PLA doesn't behave the same way, so PLA will have a matte appearance. I don't typically print in PLA unless somebody comes to me and says, I've got this thing I want printed, it has to be in PLA. So there's pros and cons for all materials, and as you progress in your 3D printing journey, you start to select materials not only because of their color or because they're the ease of printing. You print them because of the material characteristics. So let's have a look. Let's just have a quick discussion about the different materials. So like I said, we got PLA. It's okay. We'll come back to your point. Lazy man. No worries. So PLA is made from a plant material. It does biodegrade. It takes quite a while to biodegrade, but it will biodegrade, unlike things like ABS, for example. That's quite nasty for the environment. The properties of it is it has a nice, simple printing temperature range. You don't have to have a heated build platform or a heated build chamber. And it's quite a versatile material. Yeah, for sure. If in fact, if I send you if I drop a link to the Discord server that we've got, you can by all means drop. It's all right. I am being a complete buffoon here. I am being a buffoon. Could somebody just drop a link to the Discord, please? Thanks, Chris. Appreciate that. Multitasking is not the best thing for a man, and certainly not the best thing for me. But anyway, so the point I'm trying to make with PLA. PLA is a very stiff material, but with its stiffness comes brittle. For example, you could build a drone, a quadcopter from PLA, and it has extremely good sort of physical strength characteristics. However, when you crash it, there is no play, there's no flex in the material. It will not give, and therefore it will break. Ultimately, that's not necessarily a good thing. So if you want something to be structurally strong, PLA could be a good option. However, there is a negative aspect of PLA in that it has a low temperature to deform. If you were to place a PLA, say you made a cradle for your mobile phone and place that in your car, and you are on a hot sunny day, you could very well find that cradle will kind of deform and flop. For example, if you drop a PLA print in boiling water, it will deform. So it's not necessarily the greatest thing. Right, okay, let's see if I can. There we go, I got it. Cool. So, the next material in the scale is PETG, in my opinion. It is, I would say, an intermediate material between PLA and ABS. It has many of the characteristics of ABS in terms it has flexibility. Exactly. that's why I powered through that problem. But yeah, there's lots of flexibility in PETG. Some people say it's as easy to print as PLA. It's not. It is more difficult to PLA. It has many of the mechanical properties of ABS, but it's slightly easier to print. You don't need a heated a heated chamber to stop warping. Warping is where the layer cools and it shrinks. And what happens is you print a layer and that starts to shrink, and then you print another layer on top of that and that starts to shrink. And the higher you go in your print, the higher these forces are, and it can cause the model to actually split, which is not particularly great. Let me see if I can find a picture of ABS warping. That would be really useful to demonstrate the point that I am making. So let's quickly switch over to the PC and we'll see here, right? We've got this demonstrates it really, really well. Let's open this in a new tab. Open image in a new tab. There we go. So we've got the layer going down, and as the layer cools, it wants to curl up. So we print another layer on top and it wants to curl up, and so on until it pulls the print from the bed. So with ABS and PETG, I would highly recommend that you have an all metal hot end. A lot of printers come, especially like the E3D clones, they come with a PTFE liner. It's like a little PTFE tube, like a Bowden tube, but a little bit thinner. It goes down through the choke and down to the heater block, and it provides a continuous path for the filament to pass through to get down into the melt chamber. Now, when you're printing PETG, ABS, nylon, you're going to be looking at temperatures ranging from, let's say, 235 to 255. The PTFE liner will start to break down at around about 245, 250 mark. And that can cause all sorts of problems. So if you have an all-metal hot end, in theory, yes, you know, that your printer will absolutely print PETG. What you've also got to be mindful of with PETG is that it strings. Let me just finish up what I was talking about with ABS and see if I can find a print that is warped. Right, so this is the sort of thing that you get to see, right? The corners curl up, but you also get to see this. So your print, you might have a print that sits perfectly on the bed, and as you go up, you get this crack forming because the adhesion of the layers can't withstand that shrink force, that shear force, and it just breaks splits like a piece of wood along the grain line. So one way to account for that is to have a heated chamber. And the heated chamber, what that does is it slows the cooling process of ABS down, meaning that everything cools down at a similar rate, and it keeps the contraction consistent with the layers around it, and it reduces the risk of layer cracking and stuff like that. So what's the question here? No, that would probably make it worse because you've now got you've got a layer that is shrunk with a layer that's coming down hot that wants to shrink. So you'd actually magnify the problem by doing that. In theory, you'd want to print it as fast as you can, so that the whole thing prints down. Everything cools down at a consistent rate. Also afraid with PETG, my roll is sitting here since I got my printer. Won't destroy the glass bed. It sticks like hell without any anything like glue. Yeah, absolutely. My experience with printing on glass. So I've got a glass bed on my CR10 V1, and I've got the two textured glass beds on the CR10 V2s. I've never had a problem with PETG releasing from the bed. As long as the bed is really clean, you get really good bed adhesion and stuff will not come off. But here's the trick. If you let your bed cool down from, let's say you're running, my beds are running at 70 degrees. When I'm done printing, I let them cool down to 30 degrees or even cooler to ambient room temperature, and the print pretty much just falls off. There may be some prying needed. You might need to use a pry tool, but minimal. I've never destroyed a part by allowing... I have destroyed a part coming off the bed, but I've never destroyed a part coming off the bed when I have taken care to allow the bed to cool down to ambient temperatures. So that would be my recommendation. And there is a caveat to that. If you have a PEI coating, or if you have one of those magnetic beds, oh my good lord, PETG will stick like that. Nobody's business. You need to make sure that you're gapping your nozzle distance between the tip of the nozzle and the bed is spot on. Too close, you're not getting that print off that magnetic bed. You're getting a new magnetic bed. You will destroy the magnetic bed trying to get it off. Same with PEI. If you have a PEI coating on the bed, you've got to make sure your gapping's right. Otherwise, you will fuse it to that. That is a genuine concern. Are you referring to the... Right, so there's two different tubes, right? So we're talking... When we talk about a Bowden tube, the Bowden tube extends from the extruder. That's the mechanical motor that drives the filament into the hot end, right? And that is this, right? So you've got your extruder here, and it gets pushed in through the Bowden tube and into the hot end. Now, some 3D printers do not have a Bowden tube. They have a direct drive system. So where the hot end is, this, if you imagine cutting out this tube and flipping this motor on and bolting it on top of the hot end, that is what a direct drive setup is. Now, what we're talking about here is the PTFE liner. So there's this little tube. Let's see if we get a cutaway. There we go. So an all metal hot end doesn't have the PTFE liner. It might have a metal liner, and it provides a sort of access through the hot end unfettered, and it's metal. Everything's metal. Whereas with a liner, you have this little tube that goes down through the hot end and stops right pretty much at the heat break, and allows the filament to then pass into the heat break and heat up and push through the nozzle. It's that bit inside, so it's not the bottom. Not quite sure what that squeaking is referencing. I don't know. You do it. I've never tried using Magic Goo. So Magic Goo is a bed adhesion supplement, very much like a glue stick. They say that it has been formulated to aid with bed adhesion. Now, could you use that as a barrier, almost like a barrier material? I suppose. I don't really know. But then if you're using Magic Goo, why would you have a PEI sheet? That's like one bed adhesion tool embedded on top of another. Black textured bed with plain big touching surfaces of green. Is it a heated bed on the Q5? No, I don't. If you don't feel comfortable doing something, never do it, right? Because you always have the remorse of, why did I do that? Why did I do that? So, yeah. Magic Goo helps so you don't destroy your PEI. Okay. Okay. So I suspect you could use PETG on that machine. As long as you got the layer, as long as you got your nozzle distance between the bed and the nozzle tip set up, I would say, yeah, I would go with it. Yes. So that's an ABS print. So acetone vapor smoothing is a method you can use. What you do? So ABS filament is dissolvable in acetone, and for many years that was my go-to bed adhesion assistant. I would dissolve my ABS into quite a dilute form, and then literally pour it onto the bed and spread it out, and that would then create a plastic film on the bed, and I could print PLA, ABS on that, and it would be absolutely perfect. No problems whatsoever. None. So acetone smoothing is essentially where you create a chamber and you have paper towels and stuff on the inside which are soaked in acetone, and then you close it and let the atmosphere of that chamber fill up with acetone vapors. And what that does is it starts to dissolve and melt the surface of your print, and it has the effect of creating a model which is super smooth. If done right, it can look like it's something which has been injection molded. It's a pretty cool technique if you can print reliably with ABS. Right, we are 74% through with the scraper. So it'd be interesting to see what's going on. I've just noticed another defect I want to bring up. So let's just bring in the overhead camera and we shall take a sneaky peeky at what I'm talking about. That's the one. And we are inverted. So let me rotate this view. There we go. So we've got some defects here, 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 and here. And let me see if I can get the camera in a location that shows them up. There they go. You can definitely see this one pretty well. What we're seeing here is what's known as pillowing. So the model that we've got in Sprucer Slicer, I'm just going to scroll down. I'm going to grab this and drag down and just have a look at the infill that we've got. And you can see we've got quite coarse infill. And what's happening is the material is dropping down into a pocket of infill. Now we don't necessarily see that on the unironed one, but we can see some defects where that'll be interesting to see. Are they in the same place? They're very similar. So some of those artifacts are very, very similar. And that's likely because of my low infill percentage. If I upped my infill percentage, that would probably improve it the most. If I increase the number of layers, number of top layers, that probably would also improve the result here. So yeah, interesting. Pillowing. You get it when your infill is too low and you don't have enough top layers to properly cover over the print itself. Let's see if I can find a more exaggerated image of pillowing on Google. Oh, we got a wonderful example of it here. Have a look at this. Oh, well, that's rubbish. But yeah, you get the sense. So the top layer is insufficient in being able to bridge it, and it actually comes up in a positive lump as opposed to a negative dip. What we're seeing is a negative dip, and I think that's an inverse pillow based on ironing. I think that's what's going on there. Got another example of it. Yeah, it's there. Look. The infill is too low. There's all sorts of things you can do to combat that. I bet that's like so smooth, and it looks like your layer lines have completely disappeared, and it looks like something that has been injection molded, proper pro sort of result. So that's pillowing. So any more questions, guys, while we're waiting for this print to complete? Is there anything you'd like me to cover that I haven't already? You drive the direction of the conversation. And this is where chat goes silent. So how would I address that pillowing? I probably would address it by increasing the infill percentage. So Coming to infill. Infill descent density, I might go, what, 30%? Let's see what that looks like. So we've got a much tighter pattern for that now. Equally, I could say layers, solid layers top 3. Well, actually we'll make them 4, right? What would you use to print a usable rocket to cope with an engine temp? So you got to figure out what sort of engine temperatures are you going to be dealing with, right? What are we actually talking about? So the combustion is probably going to be running somewhere in the region of what? North of 500 degrees inside the rocket itself. But the problem that you're going to have is what is the actual temperature of the sidewall of the rocket motor. You might need something to interface in between that and the body of the rocket, because ultimately anything that comes out of an FDM printer isn't going to withstand those temperatures, because it's been printed at 245 degrees. It's going to melt. Lazy man, your ironing problems. Right, so let me just quickly grab this print off and we'll talk about your ironing problem. Can you, while I'm doing that, could you remind me of the question, please? Okay, I've had a bit of a failure in the bed adhesion area, but we'll have a look at that. Have you posted it in Discord? If you have, no, I don't see you in Discord. Sorry about that. But feel free to if you could, Chris, that would be awesome. If you've got sight of it. But I think Lazy Man was sharing a link, possibly to an image. Right, let me just quickly, while that's being copied over, let me just show you what we've got here in terms of the results. So I've got a bed adhesion issue on this particular print. We've broken away. We've lost it, Captain. Right. But what can we see? Well, I'll tell you what I can see. I can see exactly where my infill is. I probably need to bump this to 4 layers. But I also see that the trace of the nozzle has potentially gone. Let's have a look. It's less prominent, possibly. So there's the original. So it's definitely less prominent. So I might need to increase the Z height a little. Either that or add another layer, because that could be a perimeter showing through, I guess. That's what that could be, I suppose. But it's experimentation. Second problem is to explain the top last layer pattern is not an uninterrupted line. Instead, the slicer always chooses areas like be filled. So with ironing, you don't see this area, but like different shiny areas like grayscale. So are you saying that no worries, James, you take it easy, buddy. Appreciate you. We'll catch up soon. So are you saying that you're not getting a continuous line, and where it is continuous, it's shiny, and then you get like a dull area? Lazy Man, which slicer are you using? Everything we're using tonight is the Prusa slicer. I got it in my head that you're using Cura, and I'm not familiar enough with Cura to do these. I mean, I'm more comfortable using the settings in Prusa slicer to get this job done. So James is off to watch tank watching in Boca. I suspect he's referring to SpaceX. So yeah, I would, Lazy Man, I would give Prusa Slicer a go. Yes, I did see. That's pretty nice. Fair play. I do like. Here's another tip then for you. With ABS, if you break a print, you can use acetone painted on both of the edges, and you can glue them back together. You can use acetone as a glue because it dissolves the ABS into a liquid form, and you can actually push them together and they will recombine chemically, which is pretty cool. You want the link for Discord? Give me 1 second. Let's see if I can grab that again. Yes, I did see that. That's what made me think of the acetone glue. And I've used that a number of times. Yep, I'm gonna do that now. 1 second. Okay, link inbound for Discord. So any of you who are interested in joining the Discord, feel free to use this link. We are an inclusive community. We talk about lots of different things, from 3D printing to hydroponics, from programming to SpaceX. There's lots of different categories for everybody to come and contribute, and you can ask questions. There's a ton of people in there that are way smart, right? So feel free to join the conversation. Chris, thank you for hanging out, buddy. Enjoy the rest of your day. I hope it treats you well, and we will catch up with you soon. Take care, buddy. All the best. So, we are over time. So I stream on YouTube every Wednesday for Workshop Wednesday up until the end of this month, from 8 p.m. till 10 p.m. UK time, which is GMT +1 or UTC +1. Just going to take a quick look at Lazy Man's link. Hopefully we're in here now. No, I don't see you on Discord, and I don't see a direct message from you regarding that. But feel free to join. I don't know whether you've joined the Discord. You don't seem to be in the lobby right now. But yeah, if you join the Discord, we can take that conversation offline. So as I say, I stream every Wednesday on YouTube. I also stream on Twitch. On a Monday, 8 p.m. till 10 p.m. UK, GMT +1 plus. Apologies, lazy man. I posted the link in chat, so I'm not quite sure why you can't see it. Apologies. But like I say, you can join me on Twitch on Mondays, 8 p.m. till 10 p.m. UK time. But I am more than happy to have that conversation and assist you where I can. Feel free, as I say, if you can get into Discord or come into the Twitch stream, there are links to the Discord in Twitch also. So my Twitch is twitch.tv/IQ Workshop, and oh, I can't see yours. Yeah, I don't. Well, if you click that link, that should take you straight into the Discord, into the lobby, and you should be able to just join from there. But I can't see you in the lobby. But anyway, guys, feel free to reach out through all the various channels, social medias, and I will be back next Wednesday. I will give some thought to what the next topic will be for Workshop Wednesday. If you've got any suggestions, feel free to comment at the end of this video when it turns into a VOD. Feel free to comment and put in a suggestion of what topics you would like me to cover. I cover things such as you know, 3D printing, 3D modeling, laser cutting, programming, Arduino, all sorts. So if there's anything you'd like me to cover, feel free to reach out either on Twitter, on Instagram, Discord, wherever you can get hold of me. That will be really, really useful for me to be able to deliver the maximum amount of value I can to you. So until next time, have fun, be safe, and make something cool. Until then, see you soon.